I asked 70 different AI models to write DAX for Power BI. Some of them forgot which language they're using and started writing SQL. Some of them wrote such a bad DAX that it actually crashed benchmarking server. And the most expensive reasoning models, they actually performed worse than basic coding models. I am Maxim, and I would like to tell you about the DAXBench project I have been working on, which will help you choose the right model for the job. Let's dive right in. Here's the single most important thing you have to understand about AI and DAX. Look at this split. 360 syntax errors against 63 semantic errors, which means large language models actually understand your logic. What they're struggling with is how to translate that logic into DAX, into the proper DAX. DAX is very rigid. Skip optional parameter, it won't run. Use wrong notation, it won't run either. In a nutshell, LLMs are just bad at DAX grammar. And all of the fancy terms like context transition, filter context, row context, and such. Those are the things that we are, as developers, also struggle sometimes. So it's no surprise that LLMs struggle with that too. I tested many models across different providers. However, I wanted to focus on four biggest ones, or four main ones. When you test many models from the provider, you actually start to see some patterns. For example, when it comes to OpenAI, it usually acts as very overconfident senior developer. If you use their models, they tend to overthink the solution and overcomplicate the solution. However, if you stick to their more basic or coding models, they actually perform better. Now, DeepSeek, on the other hand, took the biggest leap from earlier models they released to the latest models. With the early models I tested, they tend to produce mix of DAX with SQL, which means it would often confuse which language it's actually supposed to write in, or that SQL was prevalent in their training data. With the latest models, 3.2, it actually writes proper DAX now. And this is the only frontier open weights model which you can run on your own hardware, assuming you have sufficient enough hardware for that, which will likely set you back for thousands and thousands of dollars. Google has been late to the game, even though they're the ones who actually developed transformer models. However, their early Gemini models were struggling a lot. Now, they also have a series of models which are supposed to run on your phone or laptop called Gemini. Those models currently tend to produce a lot of unusable DAX. This is the one that produced so inefficient DAX which crashed my benchmarking instance. With latest Gemini 3 Pro and Flash models, Google actually at the frontier and one of the best performing models. And Anthropic, the one that produces Claude, in early models, it had lots of issues, particularly with variables in DAX and scoping those variables. However, Opus 4.5, one of the most consistent and cleanest models that produce DAX. I wanted to show you an example of how sometimes large reasoning models tend to overcomplicate and overthink the solution. Albeit at this point, O3 OpenAI model is outdated. However, here's an example of two solutions. One is from GPT-5.2 Codex, which is a specific model not available in regular chat, but available in API. This model is specifically trained for coding tasks, and this model tends to stick to tried and proved solutions. Codex model solved task in 4 simple lines. Meanwhile, O3 wrote 12 lines, find variable for fiscal year, overthought the prompt completely, and produced result more prone to errors. DeepSeek, which I mentioned earlier, is the most interesting story here. As you can see, between version 3 and version 3.2, which was released recently, it took the biggest leap. On the left, you see it was producing something resembling DAX with mix of SQL. On the right, it actually produced valid DAX. On the left, model was confused about which language to use, and it used mix of both. Right, it learned to separate different languages and stay coherent. It's now one of the best open-weights model for Power BI, period. Google took big leap from Gemini 2 to Gemini 3 as well. Gemini 2 was writing highly unoptimized DAX code, which actually at one point crashed my benchmarking instance. Gemini 3 Flash and Gemini 3 Pro currently one of the frontier models that you can use for DAX. It went from 60% accuracy to 80% and finally learned how to properly use calculate and keep filters. If you're using LLMs, you're likely familiar with hallucinations already. So here, out of all of the hundreds of the results that I accumulated, I compiled some of the typical hallucinations that LLMs tend to produce. Count distinct, which is the one coming from SQL, and you will see that quite often that internally LLMs tend to first produce SQL and then try to produce DAX out of that. Therefore, it's often the case you get SQL functions instead of DAX functions. Count distinct is one of them. Dense rank, again, existing T-SQL does not exist in DAX. It's written differently. Or sales.net price, something which is possible in Python, but not possible or incorrect in DAX. This usually tends to show you which data is more prevalent in training data. Whenever models aren't sure, they tend to stick to something they know better. And it's SQL or Python, which is of course more popular languages than DAX. If you only remember one thing from this video, remember this one, because 40% of failures came from this one function, RANKX, and all due to syntax mistake. Very simple one. There is optional parameter in RANKX and DAX, and most LLMs completely forget about it. So they tend to lose one comma, which results in DAX that does not compile. Logic is perfect, but it won't work. It fails on commas, not the math. Which one should you use? If you want best overall accuracy, use GPT-5.2, or if you have access to Codex, use Codex model. If you want the cleanest code, use Claude Opus. If you want to run model locally or save money, you can stick to DeepSeek 3.2. Anything under 70 billion parameters, models, currently unusable for any real DAX workloads. Now, knowing which model to use is only half the battle. You still need to know how to spot the errors they make. I've compiled the 5 patterns that account for 80% of the errors across all of the evaluations that I ran. In the next video, I'm going to walk you through each and every one of them and show you exactly how to fix them. Subscribe and see you in the next one.